This chart plots the AI hardware market based on technical execution risk versus valuation multiples. Most of the industry's household names sit down here in the bottom right. They're reliable, but they trade at massive premiums. If you want higher growth potential without paying those steep PE multiples, you have to look toward the top left corner, the alpha zone. But operating here involves a specific trade-off. You're leaving the financial safety of established chip designers to take on significant execution risk. You are betting on companies defined by unproven hardware milestones, and in many cases, extreme management volatility. This is the realm of the industry's plumbing. We're talking about optics manufacturing, local power generation, and experimental testing protocols. These investments are binary. They rely on unproven hardware attempting to disrupt entrenched standards. If the engineering fails, the downside is total. If it succeeds, it resets the value of the entire supply chain. We have identified 4 specific hardware shifts where the engineering reality is currently at odds with market sentiment. Identifying AI infrastructure growth now requires evaluating these specific technical shifts before they reach a market consensus. This matrix compares the leaders in the race to manufacture 800G and 1.6T optics for AI data centers. To find the value here, we have to weigh technical leads against geopolitical reality. The major Chinese optics firms are roughly 5 years ahead of the West in manufacturing competence and yield. But for many investors, Chinese equities carry a severe geopolitical risk, the possibility of a total wipeout via executive order. This is why Fabrinet holds such a unique position. They are effectively the only Western manufacturer capable of capturing the optics ramp with high yield rates, bypassing the regulatory risk of the East. Within the foundries, we're seeing a similar shift away from traditional V-cell technology and towards specialized silicon photonics transceivers. Tower Semiconductor has built an effective monopoly in this silicon photonics fab market, and it's currently trading at a remarkably low price-to-book ratio. In contrast, Global Foundries operates generic logic fabs, with nodes becoming less relevant to the optics boom. Despite this, GloFo trades at much higher multiples. Niche optics monopolies like Tower currently offer lower entry points and more specialized moats than generic foundries. AI data centers are currently facing a time-to-power bottleneck. In many regions, the backlog for a standard grid connection is now 2 years or longer. This chart shows the primary advantage of Bloom Energy's solid oxide fuel cells. While the grid connection on the top path is stalled for 24 months, Bloom's on-site generation on the bottom path offers an immediate setup. But that speed comes with heavy trade-offs. You're looking at an upfront capital cost of roughly $3,000 per kilowatt, and fuel cells have a notoriously slow startup time compared to traditional gas turbines. The technical milestone that changes this equation is Bloom's ability to deliver 800-volt DC power directly to the data center racks. Standard power setups lose efficiency during multiple stages of DC to AC conversion. Skipping those steps significantly increases site efficiency, though it does require hyperscalers to adopt highly customized, non-standard rack architectures. For data center operators, the choice is between high upfront costs and custom engineering or waiting 2 years for a utility connection. For many, bypassing that gridlock is worth the compromise. Marvell's $3.8 billion acquisition of Celestial AI is one of the highest stakes gambles in the sector today. This is a showdown between 2 competing hardware philosophies. On the left, TSMC and Nvidia are using silicon ring modulators, the current industry standard, but one that is notoriously sensitive to heat. On the right, Celestial AI uses Germanium EAM technology, which is physically stable and thermally rigid. If Marvell can prove Germanium EAM is viable, they secure a monopoly over the next generation of co-packaged optics, likely generating massive revenue by 2028. However, silicon and germanium have a natural lattice mismatch. That creates internal stress. If the technology fails the strict 10,000-hour GR468 reliability qualification, the entire $3.8 billion investment could be wiped out. Meanwhile, Nvidia and TSMC are working to solve the thermal instability of silicon rings within their existing manufacturing nodes. If they fix the rings first, Marvell's proprietary alternative loses its primary value proposition. This is a binary trade. You're betting on whether an unstable chemical structure can survive rigorous stress testing before industry leaders perfect a standard solution. The traditional standard for chip reliability is called High Temperature Operating Life Testing, or HTOL. As this diagram shows, HTOL creates a major bottleneck. Every new custom ASIC design has to sit in an oven for a mandatory 42-day waiting period to verify its reliability. Reports suggest two major hyperscalers are now considering skipping the 42-day HTOL wait entirely. Instead, they would use Air's full wafer-level burn-in to test every chip in mass production. The risk of skipping HTOL is massive. If simulations are wrong, hyperscalers risk bricking thousands of wildly expensive logic and memory wafers at scale. For investors, there is also significant management risk. Taking a position in Air requires a high degree of trust in an executive team that has struggled with credibility in the past. Air functions as a high-risk speculation. You are accepting the potential for a total drawdown in exchange for a massive return if hyperscalers successfully adopt this testing shortcut. Escaping the high valuations of mainstream tech requires treating a portfolio as an active monitor of specific engineering shifts. The hardware shifts we've analyzed today will eventually invalidate legacy business models that are currently struggling to adapt to the AI cycle. Mapping these plays to your risk profile. Value infrastructure, anchored by Tower Semi and Fabrinet, offers stable entry without the high multiples of generic foundries. Bloom Energy hedges against national power grid bottlenecks. Binary speculations, Marvel and Air, carry extinction-level risk of total capital loss. Allocating to high-risk hardware requires a focus on underlying physical milestones. When the engineering is proven, the valuation follows.